Hi there, welcome back once again. This is Weblan. We want to look at fractions, comparing fractions, and in comparing fractions we are using these signs 1, 2, 3. Now, the steps that we have to follow as we are comparing fractions: number one, convert the fractions so that they have the same denominator. That is the first step. The fractions are supposed to have the same denominator. If they do not have the same denominator, you will not be able to compare them. Compare them after converting them to the same denominator. And then when you have converted them, and when the two fractions are having the same denominator, you can now compare the numerators, right? These are the signs that we are using. The first one is equal to. This one is telling us that the fraction you have on the left and the fraction you have on the right, they are equal, or they are of the same value. And then the second, this one is telling you that the fraction on the left is greater or is bigger than the one that is on the right. And then the third sign is telling you that the fraction on the left is smaller or it's less than the one on the right. These are the signs that we are using. Now, the first fraction I have here, that is number 1, I have 2 over 3. We are comparing it with 5 over 3. We said our first step is to ensure that the two fractions have the same denominator. Looking at our two fractions, they have the same denominator. So we can go to step number 2. Step number 2 is saying compare the numerators. Now we have 2, we have 5. Which one is bigger, 2 or 5? It is 5 which is bigger. So the sign that we have to put here is this sign. That is 2 over 3 is less than 5 over 3. Or in other words, we are saying 5 over 3 is bigger than 2 over 3. And then let's look at another pair of fractions. I have 1 over 3 and 3 over 2. 1 over 3 and 3 over 2. How do we convert these fractions so that they have the same denominator? Now, looking at these two fractions, the same denominator, we can get it if we think about the lowest common multiple of 3 and 2. That is the number that can be divided by 3 and by 2 without leaving a remainder. What number is that? That number is 6, right? So to get a 6, we multiply this by 2, and this we multiply it by a 3. Let's multiply. So we are saying this one we are multiplying by 2, so this is times 2 times 2. What fraction do we have? 1 times 2 is a 2, and then 3 times 2 is a 6. So we have two fractions which are equivalent here. 1/3 is equivalent to 2 over 6. And then this one, we are multiplying it by 3. Multiply by 3 and multiply by 3. What fraction do we have? 3 times a 3, we get a 9. And then 2 times a 3, we get a 6. Now, we have 2 over 6, we have 9 over 6. Remember, this fraction is equivalent to this one, and this fraction is equivalent to that one. Now we can compare. The numerators, the denominators are the same. Look at the numerators now. That is step number 2. Which one is bigger, 2 or 9? Obviously 9 is greater. So the sign here is our sign. The second fraction is bigger, so 2 over 6 is bigger than 9 I mean 2 over 6 is less than 9 over 6. Let's think of another fraction, another set of fractions, that is number question number 3 here. Two fractions. I have 3 over 7, and then I have 2 over 21. This one is easier. Looking at this one, remember we said we want to compare them. Before we can compare them, ensure that the denominators are the same. Now, this is 21. 7 can be converted to 21. How do we do that? We multiply by 3. So if we multiply this, multiply by 3 and multiply by 3, what fraction do we have which is equivalent to this one? 3 multiplied by 3 is a 9, and then 7 multiplied by 3 is a 21. This one is already having 21 as its denominator, so we don't need to change anything, so it remains the same. So it's 9 over 21 and 2 over 21. Our denominators are the same now. Let's compare the numerators. Which one is bigger between these two? 9 is bigger than 2. So there is our sign. 9 over 21 is greater than 2 over 21. Should I do another one? Number 4. Two fractions there. What two fractions can I compare? I have 3 over 4, and then I have 5 over 3. 3 over 4 and 5 over 3. All right. Without changing anything, you can actually tell that this fraction is bigger because it's an improper fraction. If we convert it to a mixed number, 3 goes into 5 ones, that is 1 whole, a remainder 2. So this can be converted to 1 and 2 over 3 there. So 1 and 2 over 3, we already have 1 whole, and this is a proper fraction which does not have a whole, so obviously this one is bigger, but let's convert them to have the same denominator, the method that we were using in the previous questions. All right, there is 4 and 3. Which one is the lowest common multiple of 4 and 3? The number which can be divided by 4 and by 3 without leaving a remainder. We have many of them, but we want the smallest, the lowest of them. The number is 12, right? So to get 12, 4 is multiplied by 3, and to get 12, 3 is multiplied by 4. So let's multiply there. This is by 3, and this is by 3, and this one by 4 and by 4. Let's get the equivalent fractions there. 3 and 3, it gives us a 9. 4 and 3, it gives us a 12. 5 and 4, it gives us a 20. And then 4 and 3, it gives us a 12. Now we have two fractions which are having the same denominator. We can now compare the numerators, right? 12 and 12. And if you compare the numerator, there is a 9 and a 20. Which one is bigger? A 9 and a 20. It's a 20, so this fraction is greater. This is how we compare fractions, making use of the concept of equivalent fractions. Remember, practice makes perfect, so continue practicing until you are perfect.